Hello students, this is Mr. Yao. Today we are going to talk about 5.8a, where we will start learning about unit circle. But we do have quite a few things we need to review before we get on to the real unit circle. We will start by reviewing about special triangles, because all unit circle is basically a bunch of special triangles putting into a circle. Now, number one, find x and y. This is the 45-90 triangle, and you are given a leg. That automatically tells you y is going to be the same. But x, since the hypotenuse, the relationship is, remember, 45 is 1 square root of 2. That is going to be 2 square root of 5 over 3 times a square root of 2. That is going to give you 2 square root of 10 over 3. That's our x. Number 2. 15 square root of 7. The 30, 60, 90 triangle is something that a lot of you struggle with. Because a lot of you are not trying to identify which is your short leg, which is your long leg. So in this case, 60 degrees is always facing the long leg. And whenever you know the long leg, you've got to find the short leg first. And here's a reminder what a special triangle is for 30, 60, 90. That's 30, that's 60. Basically, this is 1, that's 2, and that is square root of 3. So to use a long leg to find a short leg, that is going to be 15 square root of 7 over square root of 3. We're going to multiply the top and the bottom by a square root of 3. That is going to be 15 square root of 21 over 3, which is 5 square root of 21. Then the y, the hypotenuse, is just going to be twice of the short leg. So it's 2 times 5 square root of 21, which is 10 square root of 21. Number 3. First, identify your 60 degree. That is facing the x, so that is the long leg. That means my y is short leg, which is half of the hypotenuse. So 7 square root of 3 over 2. But x is going to be square root of 3 times the short leg, which in this case is 7 square root of 3 over 2. Square root of 3 and the square root of 3 becomes a 3. So the top is 21, and the bottom is a 2. That is number 3. Next, number 4. Find measure of the angles in standard position. You're given part of the things to help you. If this part is 180, the whole thing is basically having this part as the extra. So it's 20 degree plus the straight angle, which is 180 degrees. That's going to give you that actual standard position angle, which is 200 degrees. If this part is 250, well, this is the only part we need to add on extra. So it's going to be 50 degree plus a 270, because that's passing through 3 quadrants, which is 270. Altogether, that is going to be 320 degrees. Number 5, sketch each angle in standard position. You can see this is clearly bigger than 360 degrees. So we will know, we will go a full cycle first, then we will see how much. Compared to 360, this is 135 more. So we are going to keep going. 135 is around right here. So that is my actual angle. And just as practice, here's the reference angle right here. If this actual part is 135 compared to 180, this would be 45 degrees. Part B. So yeah, but this time we're going negative. So it's even though it's negative, this part is still bigger than 360. So it's going to go a full cycle and then sum. The 480 is 120 more than 360, so we're going to keep going more. And that's about where it is. Basically, this part is the actual 120 that we went through. And as practice, let's also identify the reference angle. It is actually going to be right here. And that is a 60 degree. Something else we emphasize on, make sure you actually draw the arrow to indicate which direction our angle is rotating. So that is number 5. Now let's get to the unit circle stuff. Inside a unit circle, well, let's define it first. A circle with a radius of 1 and its center at the origin of the coordinate plane. So again, a radius of 1. That basically means every single point on here has a distance of 1 compared to the origin. So we can easily write some coordinates. This would just be 1, 0. That is 0, 1. That is negative 1, 0. That is 0, negative 1. These are just points on the coordinate system that are 1 away from the origin, and since they are on the axis, we can easily write these coordinates. Now let's actually deal with the degrees. This is 0 degree, rotate this much, that's 90 degree. then this is 180 degree, this is 270 degree, going back to a 0, and of course that is going to be 360 degree as well. And since we have learned about coterminal angle, you should know by now that every single angle, you could rotate it however many times of 360 you want. They're called coterminal angles. They're going to give you different angle though. Now, quadrant 1. We are not going to focus on any random angle. In fact, there's a reason why we review the special triangle. We are only going to focus on the special triangle angles. 45, 30, and 60, and all the angles related to these three. So if it's in first quadrant, easier to identify, smallest will be 30, middle will be 45, and biggest would of course be 60. Quadrant 2. This right here is 90 degrees. So quadrant 2 is basically adding these three values to the 90 degrees. So this part is 30, so that makes this 120. This part is 45, that makes this 135. This is this is 60. Basically, that means that angle would be 150 degrees. Next, example 3. This time, this is 180, so we're adding 180, adding 30 onto 180. It's going to be 210. Adding 45 is 225. And adding 60 would be 240. Then, of course, quadrant 4, this is 270. Adding 30, that's 300. Adding 30, that is 315. And lastly, that is going to be 330 since we're adding 60 degrees. So these are the angles in all quadrants. Now let's kind of separate them, focus by the special triangles. First, the 45, 45, 90 triangle, which is right here. That marks this to be a 45 degree angle. Then, of course, we have the 90. Passing that into second quadrant, we add another 45. That is going to be 135. Add another 45. That's going to be 180. Keep adding 45. That is going to be 225. Then we have 270, 315, and lastly, 360. Now for the 30, 60, 90 triangle, we also have something similar. Start with 0 degree. That is when basically you can see the triangle is laid flat, more flat, like flatter. The 30 degree is going to be right there. Then moving up, we kind of turn it. So the short leg is on the x-axis. That will give us the 60 degree, keep going 90. And now 120, 150, 180, 210, 240, and 270. Fourth quadrant, add another, well, from 270, add another 30. That's going to be 300. And add another 30, 330. Keep going, it's going to give us 360. Now, these are the angles related to 45, 90 triangle and 30, 60, 90 triangle, and put them inside a unit circle altogether. Next, as you may have noticed, the angles we have labeled in the coordinate system are all related to the special triangles we have learned, but they are even more special. They all have a hypotenuse of 1. Remember, this is called a unit circle, which means the radius is 1, and the radius is the hypotenuse inside these triangles. Since the hypotenuse is the radius in the circle, before we put trig value into the unit circle, let's have a look at one of the special triangles first. This is the special triangle 45, 45, 90 again. But this time we're going to label the hypotenuse to actually be 1, because inside the unit circle, that side is going to be the radius, which is 1. If that is 1, that means we're going to divide by square root of 2 for the x. That's going to simplify to be square root of 2 over 2. That means my y is going to give you the same answer, square root of 2 over 2. And then the sine 45 is, so these are the values. The sine 45, you can also use the 1 square root of 2. Think about it. That is going to be 1 over square root of 2, which simplifies to be square root of 2 over 2. Cosine 45, same idea, square root of 2 over 2. This may not be super obvious, but you can see these values are kind of the same. In the 45, 45, 90 triangle, they are exactly the same. But the main thing is y is the same with sine, and cosine is the same thing with x. When graphing coordinate points, the x coordinate is its horizontal distance from 0. The y is the vertical distance from 0. And now, from what we just found out, basically my sine is y over 1 right here, which is just y. Typically it's y over r, but since r in the unit circle is a 1, it's basically y over 1, which is y over r, which is just y. Then the cosine is just x. The tangent will be y over x. Now let's really get into the unit circle and fill out the unit circle that's related to 45, 45, 90 triangle. Let's start with the angles. That's 0 degree at 145, 45, at a 45, that's 90, at a 45, 135, at a 45, 180, at a 45, 225, at a 45, 270, at a, and at another 45, that's going to be 350. Next, let's write down what we had in the previous slide. Sine theta is going to be the y value, and cosine theta is going to be the x value. Not only that, we have also talked about all student take calculus. Now, first quadrant shouldn't be too bad. Let's label the axis first. That is 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Now we can start filling out the 45. It's square root of 2 over 2, square root of 2 over 2. And next, the 135. We are going to use the same value from the 45. So the value wouldn't change. Square root of 2 over 2, square root of 2 over 2. Also because they're the same height, which means the y value, no matter what, it won't change. But since this is second quadrant, only sine is positive in here, but our x is actually cosine. So the first number will be a negative. Next, 180, we already wrote it down. 225. In this quadrant, only tangent is positive. That means my sine and cosine would both be negative. So let's write down the number. Square root of 2 over 2, square root of 2 over 2. So they're both negative, negative, negative. And 0, negative 1 is right there. Lastly, 315. Square root of 2 over 2, square root of 2 over 2. So in this case, since cosine is positive inside this quadrant, the cosine could just stay there, but the sine needs to be a negative. Lastly, you may be wondering, what are these little bar next to the coordinates? What are they? They are actually to help us find the tangent. First one, 0 over 1 is basically just 0, so that's the tangent. Next, square root of 2 over 2 over square root of 2 over 2. And that is basically the same value on the top and the bottom, so the tangent is 1. Next, 1 divided by 0, you can't do that, so that is going to be undefined. Next, square root of 2 over 2 over negative square root of 2 over 2 is just having a negative sign, so it's still negative square root of 2 over 2. Not square root of 2 over 2, negative 1. And then the 180 degree, 0 over negative 1, that is going to be 0. 225 is negative over negative is a positive, also because inside this quadrant, remember, tangent is actually positive. We have 0, negative 1. Since it's negative 1 over 0, tangent is still going to be undefined. And then next one, 315. Y over x, y is negative, so that is going to be a negative 1. And as you may notice, some of the values are seriously the same. So this is negative 1, that's negative 1, that's 0, that's 0, that's 1, that's 1. That's kind of how this works. And that is the unit circle with 45, 45, 90 triangle. That is everything for 5.8a. Thank you.